So a sequence is just a very long list of numbers. Let's say I have a sequence A1, A2, A3, A4, A5. So these are just some numbers, by the way. So if we continue, I'm going to have A6, A7, A8, A9, A10. So it will be A11, 12, 13, and 14, and so on. So maybe I don't have to care about all these numbers of individually, but we can ask questions like, okay, so we know we have an infinitely long list of numbers, we have just a bunch of numbers, but what will they eventually be? What will they eventually become? So this is called the limit of a sequence. So if all these numbers approach a certain number, I'm going to say that that is going to be the limit of my sequence. And I'm going to say that this sequence converges to that number. If, on the other hand, the numbers in this sequence, they just keep increasing and increasing and increasing without bound, I'm going to say that the limit is infinity. Or if they are negative and they keep decreasing and decreasing and decreasing without bound, then I'm going to say that the limit is negative infinity. Or it could be possible as well that the number in this list, it doesn't exactly approach any number. So we can say that the limit doesn't exist. In the three case, when the limit is infinity, negative infinity, or when it doesn't exist, we're going to say that the sequence diverges. So let's take a look at the example that we have down here. We're going to talk about an algebraic method that we can use to find the limit of a sequence in the next example, but for now, let's take a look at these just as a number. So if I have 1/2, 1/4, 1/4, 1/8, 1/16, 1/32, notice how whenever the next number shows up, its value gets decreased by half. So next thing, I'm going to have 1/64. 1/128 and 1/256. So its value is going to get smaller and smaller, but they will always be positive. So the limit of this sequence is going to be just 0. So all this number is going to approach number 0. So I can also say that the sequence converges. Okay, let's take a look at the next one. N over n plus 1, we have seen this already. The numbers in this sequence are 1/2, 2/3, 3/4, 4/5, 5/6, and so on. So if we compute all these numbers in Excel, what we are going to have is something like this. So this is 1/2, 2/3, 3/4, 4/5, and 5/6. We can see that all these numbers, so we get to 0.9, 0.98, 0.99, and they're approaching a number 1. So we can say that the limit of this sequence is going to be just 1. So I can say that the limit of an when n goes to infinity is 1, and the sequence converges. Okay, so let's take a look at the next one now. I have 11, 21, 31, 41, 51. So each time a number shows up, the value keeps increasing. The value gets increased by 10. So then the numbers in this sequence, they basically just keep increasing without bound. So we can say that the limit of an when n go to infinity is going to be just infinity, and then this sequence diverge. Now for the next one, -1 to the n, we have seen that the entries in this sequence are basically just -1 and 1 and -1 and 1 and -1 and so on. So the entries in this sequence, they alternate between -1 and 1, so that doesn't approach a certain number. So once again, we can say that the sequence diverge. So these are what it means for a sequence to converge and to diverge.